This is a remarkable achievement. This is a project that's been going for 10 years or so, but really took motivation after the signing of the UN Sustainable Development Goals in June 2015, when the governing board of the global earthquake model decided they were going to complete a global seismic hazard map by the end of this year.
The commitment of GEM in its mission and the achieved results were acknowledged by the United Nations ISDR during the European Forum Disaster Risk Reduction, which was held in Rome on the 22-23rd of November. GEM received the Damir Semerin Award in recognition of their leadership in supporting disaster risk reduction. In particular, the global model of GEM seismic risk, which provides remarkable added value in reporting expected annual losses in terms of human lives and economic losses.
This wasn't always about developing a map, even though it's the global earthquake model. As an organization, our first objective really wasn't to build a model. It was to build a framework for people to work together, to collaborate, to have common methodology and tools, to have open and transparent information, and to have a system of information that was maintainable and could be continuously developed over time. And within that process, we then have developed models and maps, and as Mauro had mentioned, a mosaic of models represents the bringing together of all that information.
But my little task here now is a real pleasure to introduce Marco Pagani as the speaker to address the hazard aspects of the GEM models. I've known Marco for quite some time, being a geologist also. It's been a really long journey, I think, for the hazard, getting the hazard connected up and across the globe.
Next part is the hazard map. And this is the hazard map that results from the combination of the maps that we calculate considering the 30 models that I just explained to you. The map is representing PGA with 10% probability of exceedance in 50 years and is referring to reference fault conditions that are in the range between 760 and 800 meters per second. As you can see, the hazard is, changes smoothly between the various models, and in order to guarantee that, what we did is to apply an homogenization procedure that is concentrated on narrow bands of a width of about 120 kilometers between the different models.
Think, or could not think, of a more suitable person to have carried out this endeavor, and I'm really, really honored and proud to call Vitor to the stage. Vitor.
As I mentioned before, we developed vulnerability functions for economic losses, but we also did the same thing for human losses, and this is the distribution of our global fatality as a risk map around the world. Just some interesting statistics. Once again, if there was a huge accumulation just on the top 15 countries for exposure, for risk, it's even more, it's even stronger. So 83%, for instance, of the average annual losses are just on the top 15 countries. And surprisingly, we have Japan, China, United States on the top. If I normalize things, now I have a very different view of the risk. Now the United States is still there, but it's obviously not on the top. We have China, Japan, Iran, Philippines, and we have a lower percentage for the top 15 countries. On the human losses, again, for the top 15 countries, it's quite interesting to see that 80% of the losses are coming from only 15 countries. And in fact, we obviously compared this with various databases of human losses, and this is unsurprisingly very much in line with past observations. For instance, I think there are two let's say, efforts or initiatives which might help us go in the direction that you just mentioned. One is, of course, the Sendai framework for disaster risk reduction. I think there will be a stronger effort in collecting the data and making sure that this data is available. And I think there's already some interesting efforts going this direction, for instance, with this Inventar, and also some USAID-supported initiatives, like, for instance, MDAT. We use a lot of information from MDAT, and it's publicly available to everybody. So some of this calibration was done with that. But this covers basically just economic losses and human fatalities. We do need the detail on the risk. I need to understand if this building has 100 years or it was built yesterday, if it's concrete or if it's masonry. So, for instance, with this initiative that the World Bank is working a lot on this, we did develop basically a sort of a taxonomy to try to classify buildings still in a simplified manner, because we know that the people that go into the field might not have this engineering degree, and also try to come up with a uniform way to do this. There will be a continuation of this project, and this is being applied already to Armenia, to the Republic of Armenia. So maybe some of the lessons from here can be expanded to other countries. But I do agree that a lot of the work that we had to do to develop this model was almost unnecessary if there would be more data available, and I would say probably in a more uniform manner.
What we are going to do is present Anna with the GEM Outstanding Contributor Award, which is given approximately once a year to an individual who is an exemplar, a champion of GEM principles for collaboration, openness, public good, credible science, and a champion for going well above and beyond to do for GEM and to represent GEM in a meaningful way.
And Peter was talking to us about the obstacles to risk assessment. So he said there is a lot of data, lack of models, lack of openly accessible tools for risk analysis, lack of expertise and local capacity, lack of international collaboration, and lack of scientific solutions. And as I was preparing this presentation, I felt very good because we have done a little of each of these topics in the last 5 years that I've been working with GEM.
And up to this point, we've used catastrophic risk models to make evident both the seismic hazards that people are exposed to, and we've used catastrophic models to also make evident the potential for loss and the cost benefits of investing in seismic retrofit. You would think that these would be the motivations that would empower people to take action, and yet they aren't. Excellent work, but still a long way to go between an understanding of risk and taking actions. So one of our focus points has been to try and understand what else we can do to overcome this gap and to build bridges between catastrophic modeling and the work that people are doing on the ground for disaster resilience planning. And the conclusion that we've come to is it's really a narrative that you need to build around things that people care about. And so we have been working on a framework of indicators that we call performance measures for disaster resilience planning that look at the whole spectrum of earthquake risk at different levels, looking at building performance, issues of public safety that are of course important for the emergency management community, but measures of recovery, disaster recovery, and social displacement, which are key for the recovery planning process within the context of urban planning. Together, these become stepping stones between an understanding of risk and actions that can be taken at local and regional levels.
Actually, this is evolution our hazard map before. We have 1966, and then we have 1970 and 1983 and 2002, and this is our map have after almost 10 years we revised using US software, and the last one we have hazard map for 2017 is already approved by public board, and we use USGS and OpenQuick software. We combine for this software. Actually, this national hazard map have been implemented in earthquake-resistant building and infrastructure design code in Indonesia. For building, we have 2,500 years return period. For bridge, we use 1,000 years return period. For metro tunnel, we use 1,000 years return period. And for dam, we use until 10,000 years return period. And then we have offshore platform, and we have railway bridge, wind port, and airport, and all we use from our basic hazard map. This is our last hazard map we have. Will be used for our last code in this year. We will finish revise our code using USGS software and OpenQuest software.
And it's been a pleasure to work with this team. So I cannot brag about being engaged for 10 years, but I hope what I will present to you today gives you the enthusiasm that we are trying to build a very interesting partnership, and we hope to help GEM to become also a standard in the financial services sector. When discussing the protection gap, when we talk about upward of 90% of people living in what considered vulnerable countries or countries in crisis, there's a very important geographical implication of that. So if we're going to be serious about working in developing countries and helping the poor and vulnerable population, it's not that we can pick around the globe and say, let's go and work in the easy countries. I mean, if you're going to be serious, you have to go to those countries. And those countries are usually the ones that have the least data available. But if we're going to make a difference, and we need to bring this financial technology and financial services for these countries, we need to overcome these constraints with the best to our knowledge. But we don't have the luxury of waiting. I mean, there's a lot of cost of inaction. So the key mandate that we received, we were funded by the British government and the German government, was try to innovate and bring these financial services, maybe not at the retail level, but at least at the institutional level, for NGOs, for investors, for SMEs that have exposure to natural disasters, so they can build financial resilience. So
panel number 1 is about the use of models and tools. And the goal of this session for the next 45 minutes or so, depending on your participation, is to get a perspective from different organizations about the use case, but also we would like to achieve some feedback from the panelists, but also from the public around the future use of these tools and models.
Are developed in-house within the companies, and I see that GEM products are already gaining a position as an independent view, as a point to compare with what we're using, a checkpoint, and much more. So
just to say that GEM is not represented only by its databases, its products, its engines, but also with a high-level staff which represent an added value for GEM.
Piggybacking off Rolando's comment that GEM is about the data and the models, but although those are necessary, they're not sufficient without the collaboration framework, which at the beginning we didn't necessarily realize was the collaboration framework is the lasting asset of GEM. And so
in panel 1, we addressed existing use cases. And the idea of panel 2 is, the intention is to discuss from a more strategic perspective drivers and demands for GEM, for the use of GEM's maps and models. Also making specific reference to the global disaster risk reduction framework, initiatives like the Sendai framework for disaster risk reduction and related initiatives.
Practically speaking, what we're seeing now is, with the availability of this information, when we start having dialogues with clients, we can actually turn now to global models and global information and data and say, you know, this is robust, this is good information, this is dialogue that we can start discussing. If you have investments that you're going to be making on infrastructure, are you doing them in risky areas?
But Sendai framework has 4 priorities of action, and it starts with understanding risk. And I mean, you cannot measure something that you don't have data for. So counting now with a global earthquake model is, I think, a great contribution towards a better understanding of risk by our constituents that are member states.
It's fantastic that actually you've got local buy-in to this. And I think this is something that has not been paid enough attention to over the years. I've just done some work in Bangladesh and the Philippines, and they love the idea that they are able to put these tools together themselves to begin to bring their own science community to bear. And I'm talking about other perils than earthquake here, actually, but the principle is the same. So I think that's really, really important, not only for the people that are using it, but for the insurance industry who want to have a conversation about risk, often with those countries themselves. So it's important that it has credibility locally. And
the main focus is earthquakes, and I don't think we want to see that get diluted. I envision GEM kind of being more of a role model for other groups and to provide kind of technical assistance in how to get there, perhaps, but I mean, that's just my point of view, but it's definitely something that I think needs to be discussed further and decided upon as a group.
That we are releasing today a number of tools. Obviously, we have the hazard and the risk posters, which you've already seen behind you. They can be downloaded also in PDF format. But we've also been working on an interactive map tool to allow users to view the maps and to zoom in, to zoom out, and to click to see the actual values and to see some information about those maps, associated documentation, and links to the country profiles. As of today, we have around 120 country profiles available. More will be coming soon.
Welcome to panel 3, Future Directions for Models. We will try to understand this in a little bit broader way. That is, we will discuss options for the work of GEM in the future more generally.
Well, we can certainly make exposure data sets far more quickly than we could 5 or 10 years ago, and we're aiming to build those more quickly and have them more appropriately designed. But one thing we're doing in METEOR is looking at the uncertainty of the results. So we can look at the uncertainty of each hazard data set, look at the uncertainty of the exposure, and look at how they interact and permeate through to the final result.
And we need a model, a portfolio model that is physics-based. We're physics-based, and we need a model that's physics-based that can take and incorporate our data and be able to not only look at it at the building-specific level, but also look at it at the portfolio level. And from the very first conversations that we had with John and Vitor, it became clear that there was a lot of synergy about what we are doing and what OpenQuake and the tools were able to do. So we're in advanced discussions about starting a project together that we can begin to look at. Now,
and in the long-term space, I think a good place for GEM to be would be to start looking at other issues of social and economics. And potentially some of that is dealing with cascading effects. I heard that come up. And also in areas of food, energy, and water. And when I say this, I'm not necessarily talking about calculating the risk, but understanding what is driving resiliency within food, energy, and water systems. And where do we have cascading effects within those systems, and how do we close resilience gaps, and also within supply chains as well. So potentially that could be a long-term avenue to look at as well. Thank you.
If we operate on those same principles of openness and public good, transparency, then there's an enormous amount that we can all do together. We need to make sure that what we do is usable, useful, and used. That what we do actually gets applied to disaster risk reduction. Now, it's often difficult to measure exactly We can't necessarily say, okay, if we do this project, how many lives will we save? But we can talk about how it can inform risk reduction.
We can all of us acknowledge that GEM is really a mine that is grown up in 10 years only. For a mine is a record. And there is so many minerals, precious minerals inside. And I believe that now we have to extract gems from the GEM mines with great attention. And I believe that this global risk model is just one of them, perhaps the brightest now, but not the only one. Thank you.
So it's left to me to wrap up and send you off into the night. I want to do that with two thoughts that we've heard a lot about. One of them is that idea of partnership and collaboration. And the point I think that Ricardo, I think it was made about that the product is amazing, but perhaps the process is actually the legacy of GEM that's going to be the most important, about creating alliances between and partnerships between scientists and engineers, between scientists and social scientists. That's an incredible kind of legacy that will continue, the legacy of dialogues.
I feel honored to be able to stand here and thank the GEM staff for everything they've done. So could I have Vitor and the risk team, Marco, the hazard team, Paul, the IT team, and all of the support staff, please come up here and take a bow.
I'm going to try as well.
I'd also like to invite Jill to come up. My wife Jill, I cannot thank enough for everything she's done. She has been, to say an extension of staff wouldn't be right. She's properly a part of the staff. She's been taking photographs all day, you may have noticed, but she helps every day in ways that I cannot explain. So, Jill, Jill is part of the GEM secretariat in a very important way. So, we need photographs. Anybody else want to say anything? Okay. Thank you, everybody, for everything.